So like I talked about with this unit is all about lines. So that's why we are reviewing some of the things related to lines. We're reviewing two ideas today, writing equations of lines and solving systems by graphing. So there are two different forms of a line, or two main ones. So if I were you, I would highlight these. There is slope-intercept form, which we saw and graphed, and there's point-slope form. That one we haven't reviewed yet, but you learned it last year. Slope-intercept form. In order to write the equation of a line, we need the slope, and we need the y-intercept. And as a review, the y-intercept is 0, y. So if we draw ourselves a picture, if our line is something like this, we can very clearly identify the y-intercept is the point 0, 2. And we can very clearly see our slope change by 2, change by 2. So y changes by 2, x changes by 2, so we get a slope of 1, but it's negative. I probably should have written the form. Slope-intercept form is y equals mx plus b. So we have our m, we have our our slope rather, we have our y-intercept. So our equation would be y equals negative 1x plus 2, or negative x plus 2. That is the very first form that you've learned when writing the equation of a line, and you've seen it many times. This is pretty limiting, though, because you have to have the y-intercept. Point-slope form tells you exactly what you need. You need any point and the slope. Any point and the slope. This is the one that I think many of us learned last year, but maybe not everybody. Point-slope form. This is the one that looks like y subtract y1 is equal to mx subtract x1. The slope is m, and any point is that x1, y1. So an example of this would be here. This is a poor example. If we looked at this graph, it's not the most accurate, but you're looking there and you would think to yourself, I'm not really confident what the y-intercept is. I'm not really confident, but I do know that I have any point. I have these 2 points, and I could certainly calculate the slope. Because my example is poor, we're just going to leave it there. And we'll do some examples. I always go in this form. I ask myself, do I have the y-intercept? Yes, great. If not, I use point-slope form. Technically, as you can see at the bottom, there's one other form. Do you remember what the last form is? Standard form. We are not going to write any in standard form because it's not that helpful. So there is standard form, which we're going to graph, but we're not going to write. Okay. So, question 1. Write an equation for the line. Yeah. Write an equation for the line. So I would ask myself first, do I have the y-intercept? Do I?
Yeah.
Yes. very clearly I can see the y-intercept is the 0.02. Because I have the y-intercept, I'm going to use slope-intercept form. So I have the intercept. All I need now is my slope, which I can just count on the graph. If I go from point A to point B, I go down 2 over 2. So for my slope, y changes by 2 when x changes by 2. Is this slope going to be positive or negative? Negative. So it actually ends up being the same as what we wrote above. So our line, or our equation, is y equals negative 1x plus 2. You don't need the 1 there. You can also write it as negative x plus 2. Does this seem familiar? Yeah. Questions before I keep going? Okay, so let's take a look at question 2. Question 2, we can see the y-intercept. It's right there. Do we know clearly what it is? No. So because we can't see the y-intercept very clearly, we are not going to use slope-intercept form. We are going to use the other form, which is point slope. So we can't see the y-intercept, so we're not going to use slope-intercept form. So we're going to use point slope form instead, which tells us exactly what we need, a point and the slope. We can very clearly see 2 different points on the graph, so we're going to use those. Berkeley, would you like to use point A or point B? Point A. Can you tell me the coordinates of point A, please?
2 and
2,
2.
2. Okay, so that is the point we're going to use. Charlie, can you tell me the coordinates of point B, please?
5, 3.
5, 3. Thank you. Okay, so we have a point. Berkeley chose 2, 2 for us. Charlie also gave us the other point of 5, 3. Maddie, can you remind me how to calculate slope?
Wait, slope?
Yep.
Y equals mx plus b.
How do we find the m part? Think back to the warm-up. First 2 problems we did on the warm-up.
X2 or y2 minus y1 over x2 minus x1.
Great. Marin, can you plug in the numbers, please? Thank you.
Okay, 3 minus 2 over 5 minus 2.
Okay, so I think we get 1/3. Does that look right? Okay, so slope of 1/3 and point of 2, 2. As a reminder, we have y minus y1 is equal to m, x minus x1. I'm going to use this point, this slope. So I have y subtract 2 is equal to 1/3 x subtract 2. If I don't tell you otherwise, leave it in that form. Just leave it like that. There's no reason to change it. Okay, questions? Okay, I want to write down a few more things. Can we flip to the next page so we can find 1 or 2 more examples? Okay. I would like to do example 5. The line that is passing, we're writing the equation. Write the equation of the line passing through 2, -4, and 3, 1. Do we have the y-intercept? No. So we don't have the y-intercept, which means we're going to need point slope form. We can't use y equals mx plus b because we don't have b. We have 2 points to choose from, so that's great. What we're missing is the slope, so that's what we're going to find next. Kaylin, can you set me up for finding slope between those 2 points, please?
1 plus 4 on the top and -3 minus 2.
Terrell, is she correct to be adding in the numerator? 1 add 4? Okay, so what would you do in the numerator instead? Okay, and what happens when we subtract a negative? Makes it a positive. So I want to make sure we know that's why Kaylin did that. Okay, so in the numerator, we get 5. In the denominator, we get -5. 5 divided by -5 is -1. So now we're going to use our point slope form. Janet, would you like to use the first point or the second point? The first point. Let's use the first point. So we have y subtract -4 is equal to -1 x subtract 2. I do want us to simplify that negative. So this becomes y add 4 is equal to -1 x subtract 2. Now, there are a few things I want to make sure we know how to do with this. So you're going to need a little bit of space above it. Do we know how to put this into slope-intercept form if I asked us to? So if I wanted us to put this in the form y equals mx plus b, how could I do that? Distribute. Okay, so I'm going to distribute the -1, like Terrell just said. So I would get -x add 2. And then, Terrell, what did you say? Subtract 4. So we would get y equals -x subtract 2. So both of those represent the same line. Just 2 different forms. Now, don't do that unless I ask you, because why do extra work? Okay, I want us to write this part down. So please, even if you didn't write that down, write this down. I think a lot of times in math, we just memorize things and we don't actually understand what we're finding. So I want to make sure we understand what that is. So this equation represents all pairs of x and y. So this equation represents all pairs of x and y that make the equation true. Also, it represents all the points on the line. So what a line is it's all the pairs of x and y that make this relationship true. So if I were to ask you something like, is the point 5, 0 on this line? We would plug in 5 for x. Is the point 5, 0 on the line? I'm going to write, don't write this part because you don't have the room for it. So is the point 5, 0 on the line y equals -x minus 2? The point has to be true. It has to make the equation true. So if I plug this in for my x and y, I get 0 equals -5 minus 2. What is -5 minus 2? -7. What does this tell us when we get 0 equals -7? Not on the line. So that point exists, but it doesn't actually fall on our line. I want to do one other problem, and then I'm going to give you all some time to work on this. You with me? Okay. I would like to do 11. Find the value of x that satisfies the given conditions. The line that contains 4, -1, and x, -6 has a slope of -5/2. Okay. Keyword, slope, and we have to find x. So if it is referring to slope, even if we're not sure what to do, we should probably start by setting up the slope between the 2 points that we are given. Zulkarnain, can you please set up the slope between those 2 points?
Can you choose any coordinate?
Yep.
Y plus 1.
So use the numbers that we actually have, though.
Yeah,
So this is x, y, x, y. So should we be starting with x or y in the numerator?
Y.
Y. Which y would you like to start with, the -1 or the -6?
-6.
Okay, so I'm going to have -6, and then what? What do I do with the other y?
You subtract it.
Subtract. So -6 subtract -1. Thomas, can you help us in the denominator?
Would it be x minus 4?
X minus 4. Okay, great. So let's simplify then. Anessa, how does the numerator simplify? -6 subtract -1.
-7.
Sure?
-5.
-5 over x minus 4. But we already know what the slope should be. It tells us the slope has to be -5/2. Now, here's where we might get a little messed up. That negative, it belongs to the 5 or the 2, not both of them. Considering the 5 is negative over here, don't you think it would be convenient to make this 5 negative also? Okay, so the equation that we get then is -5/2 is equal to -5 over x minus 4. And that's what you are solving. I want to talk about 7 real quick because a few people have asked me about it, and so I just want to address this as a whole. So let's take a look at 7. We should have started by calculating slope, did we? For those of us who got here? Yeah? So I would do -7 subtract 4 over -3 subtract -3. So -11 over 0. What is it when we divide by 0? Undefined. Okay. Anytime you see undefined slope or a 0 slope, your line is either horizontal or vertical. So undefined and 0 slope. These are, I'm going to call them special lines. They're horizontal or vertical. So that means either x is staying the same or y is staying the same. If we look at our 2 points, we notice that y is changing, which makes sense with our slope, but x is not. So we look and we say, x is the same value. X is not changing. X is not changing is a vertical line. So your equation is just plain old x equals -3. No matter what the y value is, x is always going to be -3, which will give us a vertical line, going through the x-axis. Does that help? At this point, we've talked about lines. And I want to remind us what we wrote at the top, that a line just represents all of the pairs of points that make an equation true. So there are infinitely many of those points that make the equation true. Are we all okay on graphing?
Yes.
Yes? Okay. The second thing we need to do is we are going to add on and we're going to solve a system. So this is what I want you to write down. What does it mean to solve a system? You are finding any points, and in parentheses, I'm going to put solutions that make all equations true. So we are finding any points or any solutions that make all equations true. For lines, this will be the point of intersection. Okay, so we are going to do examples 13 and 14. So in example 13, it says, consider the system. Use two methods to confirm that the solution is 3, 1. Okay, so this point has to make both equations true. So for our first method, we're just going to plug it in and show that it makes the equations true. So our x value is 3 and our y value is 1. So in the top equation, y equals x minus 2. I plug in y is 1, x is 3. So I get 1 equals 1. So what I've shown so far is the point 3, 1 is in fact on the top line. It does make the top line true. Now I have to try the second one. So now I'm going to do my 2x add y equals 7. So I plug in 3 for x and I plug in 1 for y. So I get 6 add 1 equals 7, or 7 equals 7. So that is the first way. That is method 1. I have just shown, or we have just shown, that this point is on both lines. It does make both equations true at the same time. Method 2, which is what we're going to do now, is by graphing. Okay, I am going to start by graphing this top line. That has a y-intercept of -2. And then it has a slope of 1. So we will go up 1 over 1, up 1 over 1, up 1 over 1. And you see the pattern. So that is my top line. And again, just what does it represent? It represents all of the points that make the equation true. Now this second line, 2x add y equals 7. Do we see that it would be really easy to get y alone here? What do we have to do? Subtract 2x. So I'm going to do that just because it's only one step. Kala, what is my y-intercept now? The 7 or the -2? The 7. Okay, so we're going to go up to 7. Terrell, what is my slope then? -2. So think of it as -2 over 1. And I have now shown geometrically in a graph that these lines intersect at the point 3, 1. So we found the point that makes both equations true, and also, as a picture, is where the two lines intersect.
We always have to use two methods.
No, no. I just want to make sure we know what we're doing. Okay. I'm going to allow you guys to do 14 on your own. Go to the next page, please. Okay. We are going to do, let's say, 15 together. 15. We now are just solving the system. So I haven't given us the answer. We have to find the answer. So I'm going to start by graphing this top line. AJ, if I were graphing that top line, the y equals 2x minus 3, what would I do to start?
Start with the y-intercept,
Okay, which is what?
-3,
Okay, what direction do I go from the origin?
down.
Down. Thank you. Charlie, what do I do from there? I've graphed the y-intercept. What's next?
You do the x one, so you go up 2 over 1.
Okay, great. Up 2, am I going to go right 1 or left 1?
Right.
Right 1, because I have a positive slope. Okay, I don't have a straight edge on this program, but you all should, so please make your line as straight as you can. Mine's not great. Okay, now we're graphing this second one. What I told us to do before is find the intercepts. That's what we're going to do. It's not as easy to solve for y in this one. So if I make x 0, I have 6 times 0 minus 3y equals 9. So negative 3y equals 9, and y equals negative 3. So that is the point 0 comma negative 3. So 0, negative 3. Right there. You can't, we're not done. We have to graph the rest of the line. Do we see, though, that it looks like we might have found our solution? Okay, great. Now let's make y 0. When we do, we get 6x, subtract 3 times 0 equals 9. So 6x equals 9. Ooh, this one is not as nice. 9 divided by 6. Let's try to simplify that. What are those both divisible by? 3. So if I divide by 3, I get 3 over 2. What is 3 over 2? 1.5. So that is the point 1.5 comma 0. So 1.5 comma 0 is right there. Looks like we found another solution that's the same. Do we see that we end up with the same line? So there's more than one point that they all share in common. Do we know what the answer is then for this? Very close. Infinitely many solutions. So infinitely many solutions. Most of the time that's not going to be the case. Most of the time they're going to intersect at a single point. Okay, I want to talk real quick. It's not all real numbers. Here's why. All real numbers means I could plug in any numbers at all that I want. Is it true based on these lines that I can plug in any x and y that I want? No. The point 0, 1 isn't going to work, right? It's not on the line. The plug negative 3, 0 isn't going to work. If I plug that in, it's not on our lines. That's why it's not all real numbers. Quick thing to remind you of. So there's infinitely many solutions. What is the other special case?
0.
No solution. So write this down. No solution. What would that look like? Or what would that mean?
The lines are parallel.
Lines are parallel. So the lines are parallel. They do not intersect. Was this of enough of a review for us to get us started on the rest of this?
Yeah.
Yeah. Your homework then is to finish this review, including that question 14. So make sure you go back to that question 14.